So welcome to the lesson on the respiratory system. So today what we're going to look at is how our respiratory system works, the structures that are associated with it, the functions of those structures, and then how our treatments can affect the respiratory system, or how the respiratory system can also affect our treatments. So first of all, let's look at our respiratory system. So a really good diagram to look at is this here. So what we can see is that we've got two areas where air can enter the body. We've got the nose and the mouth. As air enters the nose or the mouth, it filters down past the back of the mouth and down into the throat. And in this region here, we call this the pharynx, the back of the throat. We've got three areas. We've got the nasopharynx, which sits more towards the back of the nose. This is where our adenoids are. We've got the oropharynx, which is where our tonsils are, more towards the back of the throat. And then we've got the laryngopharynx, or the larynx, which is where the voice box is located. So as air comes in through the nose or in through the mouth, it passes down and past this larynx or the pharynx region and past the naso, the oro, and the laryngopharynx. As the air then comes down, it filters past a structure called the epiglottis. The epiglottis is a little flap. Now we know that as we come down the neck, we've got two tubes. We've got one for our air and we've got one for our food and our water. So our air pipe, or our windpipe, is known as the trachea. And that's where we want our air to go down into our lungs and back out of. It's really important that food and water don't go down that pipe, and we don't really want air to go down our food pipe, which is called our esophagus. So we've got this clever little feature, which is a little flap. And when we're breathing in or out, this epiglottis, this little flap, will flap across the esophagus, across our food pipe, to stop that air going down into our stomach. And when we're swallowing food or water, the epiglottis will flap across the trachea to stop the food or water going down into our lungs. So as we breathe in through our nose or our mouth, that air passes past the pharynx and then past the epiglottis, which will be covering the esophagus, so that air can come down into our trachea. So our trachea is this structure, this straight structure that's coming down from the throat and down into the thorax. After our trachea, it then branches off into two structures called the bronchi. Those bronchi are where the structures enter our lungs. So the air is coming through the nose or the mouth. It bypasses past the pharynx, down in the trachea, into the trachea, and now down into the bronchi. Our bronchi then branch off into smaller branches called bronchioles. And at the end of the bronchioles, we have little structures called alveoli. I want you to think about alveoli as little feet dipping their toes into pools of blood. So what happens is we breathe in, and the main gas that we're wanting to get into the body is oxygen. So we're breathing in that air, it's coming in through the nose or the mouth, past that pharynx at the back of the throat, down into the trachea, down into the bronchi, through the bronchioles and into the alveoli. Now, the important part is that because those alveoli are dipping their toes into those pools of blood, the oxygen that I've taken in through my nose or mouth and has come down into the trachea, the bronchi and the bronchioles, then deposits that oxygen into those pools of blood. Those pools of blood are then taken to the heart via the pulmonary vein, ready for the heart to beat, to push that oxygenated blood to all of the cells of my body. Then the reverse will happen. So the deoxygenated blood will come back from the heart to the lungs via the pulmonary artery. Those little alveoli in their pools of blood will pick up the deoxygenated or the carbon dioxide, and then the reverse will happen. So that carbon dioxide will come in through the alveoli, in through the bronchioles, up the bronchi, up the trachea, past the pharynx, and then out of the nose or the mouth. So that is our inhalation, bringing oxygen into the body, and our exhalation, getting rid of carbon dioxide, which is the waste product. Now, when the air enters our body, it's important that it's filtered. So, particularly when we breathe in through our nose, we have an extra layer of protection. And inside our nose, you'll remember from the integumentary system or from our cells and tissue system that we've got hair-lined skin on the inside of our noses, and that those hairs are called cilia. So we call that ciliated tissue. It's a type of epithelial tissue. And so as the air enters through the nose, those tiny little hairs filter that air to avoid any nasties, any dust, any environmental waste, or also viruses and bacteria from entering the nose. So those cilia, or that ciliated epithelial tissue, which is in the lining of the nose, is a first line of defense. And often if that gets irritated, that causes us to sneeze, to expel whatever it is we've taken in that our body doesn't like. Another form of defense as the air comes through, and this is either through the mouth or the nose, is the adenoids and the tonsils. So they form part of lymphatic tissue, and they help to give extra immunity to the respiratory system. We know that we can live without our tonsils and our adenoids because they are removed on people, so we can live without those structures, but they are a supportive structure to the immune system of the body, lymphatic tissue, and so they help to filter or to arm the body against any nasties that could come in via the respiratory system. So what happens when this oxygen enters our body? So obviously we know that that oxygenated blood, or the oxygen-rich blood from the alveoli, is taken to the heart via the pulmonary vein, and then the heart beats and pumps that oxygenated blood out to all of the cells of the body. So we know that our cells need that oxygen for survival. So the cells take on that oxygen and then they give back off carbon dioxide as a waste product. That carbon dioxide is then in the blood, it comes through then the veins back towards the heart, and then when the heart beats, it sends that deoxygenated blood back to the lungs to get rid of the carbon dioxide via the pulmonary artery. So we can see breathing or respiration in 5 different aspects. So the first aspect is external respiration, is that we all know as breathing in and breathing out, and that's breathing in our oxygen and breathing out our carbon dioxide. So that is known as external respiration. It's us respiring with the external air. Our next part of respiration is where the exchange of gases happen in the lungs. So at that alveoli, those little feet dipping their toes into the pools of water, we've got the oxygen being dropped off to be taken to the heart, to the body, and we've got that carbon dioxide being picked up to take into the lungs to exhale and breathe out. Now, how does that oxygen and carbon dioxide get around the body? Well, it's transportation, so it uses blood. So the blood supply, the arteries and the veins working to and from the heart and the lungs get that oxygen and carbon dioxide to circulate or transport it around the body. We then have internal respiration, and this is where, like our external breathing in and out, this is what our cells do, but rather than have a mouth and breathe in and out, we know that the oxygen is filtered into the cell and the carbon dioxide comes out of the cell. We call this internal respiration. So it's the type of breathing or exchange of gases that is happening within the cell. And lastly, our 5th segment, we've got cellular respiration. And this is the cell using the carbon dioxide and using the oxygen, and creating the carbon dioxide. So we call that cellular respiration. It's how the cell is using its oxygen and then creating its carbon dioxide. So we need to remember that the lungs and the heart are really closely linked, and they work together using pulmonary circulation. So the circulation of blood between the heart and the lungs is known as pulmonary circulation. And the main vessels for this is the pulmonary vein and the pulmonary artery. The pulmonary artery is going from the heart to the lungs. Remember, artery is always away from the heart. And the pulmonary vein is coming from the lungs to the heart. Remember, veins are always towards the heart. Now, how can this impact our treatment? So let's think about our breathing. In different situations, our breathing will happen in many different ways. We've got three main types of breathing. Our first one is apical. Apical breathing is shallow breathing. It's like the breathing I'm doing right now, just enough air to get the next sentence out, to think about what you're saying, to grasp a little bit of oxygen, ready then to create your next sentence. It's what a lot of our clients might be doing when they first come into the salon, possibly because they've walked up the stairs or they've been rushing from work, or because their stress levels are high, and that's creating much more shallow breathing more often for them. Next, we've got lateral costal breathing. And this makes sense because if you think about, we've got our intercostal muscles that sit between the ribs. This is a little bit more of a normal breathing style. So quite a relaxed breath, probably what you'd be doing sitting, listening, or watching this video. So we're starting to engage those muscles that sit between the ribs for a little bit more of a deeper breath. We'd hope that as we start our treatments, our clients settle into lateral costal breathing fairly quickly. And lastly, we have diaphragmatic breathing. So again, like the name says, this now engages another big muscle of our breathing, which is our diaphragm, a big dome-shaped muscle that sits underneath the lungs and flattens as we breathe in and raises as we breathe out. Diaphragmatic breathing is deep, very relaxed, sedated breathing. It's the type of breathing that we would really like to get our clients to very early on in their treatments, but more often than not, it takes a little while for them to get into that breathing. It's a bit of that, we call it the relaxed breath. It's when we know that relaxation has begun. And so that's really where we want to get our clients to. Diaphragmatic breathing means optimum intake of oxygen, optimum release of carbon dioxide. It means that the cells of the body will be being fed with the right amount of nutrients and oxygen. Their mind can relax, their muscles of their body will work better, blood will be circulating well, and it'll be really oxygen-rich blood. So really important to be aware of the different styles of breathing and understanding how that can impact our treatment. And as clients relax, feel comfortable, and are able to open up a little bit more into their treatments, you'll find that that diaphragmatic breathing can happen much quicker. Just to look at those muscles that we talked about on the diagram. So our intercostal muscles are little muscles that sit in between the ribs, and they allow a little bit of expansion and relaxation of the rib cage to enable the lungs to expand and deflate. And then our diaphragm is this domed shaped muscle that sits underneath the lungs. This will lower when we're breathing deeply. It means that we're filling all of this area of our lungs right down into the base. So actually, when you notice clients deep breathing, you don't notice their chest rise and fall. It's actually their tummy, their digestive organs that rise and fall. Because when the diaphragm flattens, it actually pushes, it gives less room for the digestive organs. And so actually it pushes this area of the abdomen out and in more so than you would notice their chest region. So it's really good to be mindful of what, how our treatments can affect that respiratory system. So to recap, respiratory system is made up of lots of structures. So air will enter the nose or the mouth and come past and down the back of the throat or the pharynx. At the pharynx, we have three sections. We have the nasopharynx, where we find the adenoids. We have the oropharynx, where we find the tonsils. and we have the laryngopharynx, or the larynx, where we find the voice box. As air enters, it comes past that pharynx region, down into the trachea, and then branches off into the bronchi, which then enter the lungs. As the air comes down the bronchi, it then branches into smaller branches. Think of a tree. So this is like the trunk of the tree. We've then got those big branches of the tree, and now we've got sort of the roots or the shoots of the tree, or the smaller twigs coming off as the bronchioles, which then branch into those alveoli, little feet dipped into pools of blood. That's where that exchange of gases will occur. Remember, we've got those filtering systems in here. So we've got the ciliated epithelial tissue, that lining of the nose. Tiny little hairs are there to trap any nasties that we breathe in, only when we're breathing through our nose. But then remember, we have our nasopharynx and oropharynx in this pharynx region that will again help to protect the immunity and support the immunity of the respiratory system. Remember, we've also got that very clever structure where we've got those two tubes, our esophagus for food and water and our trachea for air. We've got that little epiglottis, little flap that when we're breathing in will flap over the esophagus, and when we're eating or drinking will flap across the trachea. So if you try it now, you can't breathe in and swallow at the same time because the epiglottis stops one or the other from happening. Remember that route of that oxygen and carbon dioxide. So we've got that external respiration, that breathing in and breathing out, the oxygen coming from the air and us giving carbon dioxide back out to the air. So we call that external respiration, the breathing in and breathing out. We've then got that exchange of gases in the lungs. So at the alveoli, at the toes, they're dropping off oxygen. Oh, thank you very much. We'll take that to the heart and we'll send it to the body. And they're picking up the carbon dioxide. Oh, thank you. We're going to send that back up and out of the nose and mouth. We've then got that transportation. So how does this oxygen carbon dioxide get from the lungs to anywhere? So it's transported via the blood. So that oxygen-rich blood is taken from the lungs to the heart beats and pumps that out to the rest of the body. The rest of the body then brings that deoxygenated blood back to the heart. When the heart beats, it also takes the deoxygenated blood to the lungs, ready to breathe out that carbon dioxide. We've then got internal respiration. So that oxygen-rich blood has got itself to the cells, and the oxygen deposits itself, and the cells say, oh, thank you very much, I'll have that. And here's the carbon dioxide we don't want anymore. So that's called cellular respiration, internal respiration, where the exchange of gases is happening within the cell. And then finally, we've got cellular respiration of the cell using that carbon dioxide. So what it does with that oxygen, when it comes into the cell, and what it then does to produce the carbon dioxide to release out. We know that our treatments are going to be fantastic for clients' respiratory systems, not only supporting the health and the immunity of those systems, but helping with deep breathing. And by deep breathing, we're then supporting all the other body systems. We're making the blood circulation better. We're helping to relax the mind and the muscles. We're helping to sedate the nervous system. We're introducing more of a parasympathetic or a relaxed state for the client to be in, to encourage more relaxation, to perhaps encourage sleep, fullness, or a better night's sleep, but also to remind clients of their breathing. And so hopefully the more they feel that relaxed breath and familiarise themselves with that relaxed breathing, they could educate themselves and take that home to use in between their treatments as well.